In this section, we'll be discussing rational expressions. Rational expressions are another word for fractions, and these fractions will have complex information on both the numerator and the denominator, and we're going to be asked to reduce or simplify these fractions. Some of the study tips that you'll see along the way, for example, factoring, which we've already learned in section R.7. Factor first by canceling any factors, because we all know you can cancel things that are alike. As a review, don't forget when you're doing fractions, you can break numbers up. So for example, let's say I have 21 divided by 15. If I was asked to simplify this fraction, you could break 21 down into a product of its prime numbers. 21 is equal to 3 times 7. 15 is equal to 3 times 5. Since they both have a common multiple of 3 that divides into those numbers as factors, we can reduce those and we could be left with 7 over 5 as a reduced fraction. That's the exact same concept that we will be using for these more complicated type fractions that involve variables as well. So let's start by factoring. The numerator is only one term, so there's nothing I can do to the numerator to break it down more fully. The denominator has two terms. There is a greatest common factor for both of these. It happens to be 6x. When I pull that 6x out in front, that leaves me with 2x minus 1 inside. I cannot break up this family or this set of parentheses by reducing individual terms inside of it. When terms are being added or subtracted, they may not be broken up. In other words, they may not be reduced individually. But since this term on the outside is being multiplied in front, I can reduce anything in this term with anything in this term up here. You can see that for 24 and 6 both have a common 6 in common. So we can take away from the 24 and 6, we can reduce 24 over 6 to 4 over 1. In addition to that, we can also reduce the x's. You'll see that there's two x's up here, but only one down here. So one of these x's will reduce with this x, but that'll still leave me with one additional x up here because I had two to begin with. Once I reduce all of that, that leaves me with 4x up top, and down below, all I have left is 2x minus 1. It's no longer needed in parentheses since there is nothing outside that's getting multiplied in. This is the reduced form. Again, let me reiterate, you cannot reduce this 4 with this 2 because this total term is being added or subtracted to another term. And these two terms are acting as a family and they may not be broken apart unless that 2 is being multiplied out in front inside of a set of parentheses. So you may not reduce this further. Let's try this one. Let's factor first. You'll see that the numerator has an x in front, and we can reduce that by saying 1 minus x inside. Underneath, you can see that these can be factored also into x minus 1 and x plus 2. Now you're going to notice that this and this look very similar, but they're actually not. They're exactly opposite, meaning the signs are opposite. This is a positive 1, this is a negative 1. This is a negative x, this is a positive x. When items are exactly opposites of each other, what you can do to correct that is take a negative out in front. So if I take a negative out in front of this, if I take a negative 1 out of this, that's going to leave me with the opposite inside. So that'll leave me with a negative 1 inside and a positive x. See, notice if I distribute that, negative 1 times x is negative x, negative 1 times negative 1 is positive 1. All I did was reverse the order and make them now the opposite sign. And now that's going to look a lot like what I have underneath, which is x minus 1 and x minus 1. We can reduce those whole families as long as they stay glued together like that. So that's going to leave me with negative x over x plus 2. Multiplying and dividing we can do by moving and multiplying straight across. But it's always easier to simplify first. If you simplify first, you'll find that multiplication becomes much easier. So I'm going to simplify. If I put all of this in top, 30 times 28 over 42 times 45, it's easiest to find common things that can simplify. I know that 30 and 42, let's do 30 and 45, those have bigger numbers. 30 and 45 both have a 15 in common. So 30 divided by 15 is 2, 45 divided by 15 is 3. So 30 over 45 reduces to 2 over 3. In addition, 28 and 42 can also reduce. They're both divisible by 14. 28 divided by 14 is 2. 42 divided by 14 is 3. So when I put all of that into my calculator, you're actually going to have 2 times 2, which is 4, and 3 times 3, which is 9. Now on your calculator, these become a little more simpler. Okay? If you were to do this on your calculator, I'll put it over here. You can put this all in as a fraction. Most calculators have a fraction key, which is an ABC key. So if I put in 30 over 42 times 28 over 45, it will automatically reduce this down to you to 4/9, which was our answer. Now you can't put variables into your calculator, so you're still going to need to know how to do these by hand. Okay? So let's start by factoring first, because that's what the study tip tells us to do. So let's factor what's up here. This has a greatest common factor of 3. So if I pull the 3 out, I'm left with x plus 7. This is a difference of 2 squares. This is x plus 7 times x minus 7. You'll see that this x plus 7 and this x plus 7, the total family can be reduced. There's more that can be reduced. You'll also notice the 3 and the 9 can be reduced to 1 over 3. There's actually still one more thing. We can also reduce this x with this x. There's 7 here, but only 1 here. So let's reduce this 1x with these x's, but it's still going to leave me 6 of them underneath. Now that I'm fully reduced, everything up top, I have 1. That's it. Down underneath, I have 3 times x to the 6th times x minus 7. Another tip is to make sure that you're multiplying straight across. There is no cross multiplication here. Cross multiplication is meant for something completely different, not in multiplication problems. So when we multiply fractions, make sure you're going straight across the top, straight across the bottom. Do not cross multiply. The only thing you can cross is cancel, but we're not multiplying across diagonally. When we divide, what you're going to do is you're going to flip the fraction in the original denominator and then multiply like we did above. So we're going to take the numerator, we're going to multiply that times the reciprocal of the denominator. And then do like we did up here. First we're going to reduce 3. This 3 and 12 can be reduced to 1 over 4. And that's it. So when we multiply straight across, we get 1 times 21 over 4 times 2. And that's our reduced form. Now this is an improper fraction, and that is perfectly okay. Some students will want to put that into a mixed number, which would be 2 5/8. 2 5/8 is also okay, but most of the time in algebra, improper fractions are better. Plus, they're easier because you don't have to make the extra step. So my math lab most of the time is going to want the improper fraction form. Moving on down to this one, we have the numerator, which is 2x over x squared minus 49, and then we flip. This is times 9x plus 63 over 3x minus 15. Now you're going to notice that we're going to need to factor. So let's go ahead and factor everything that's up here. 2x over, this is the difference of squares. So x plus 7, x minus 7. This has a greatest common factor, which is 9. 9 times x plus 7 over, this is a greatest common factor of 3. So x minus 5. Then we reduce whatever we can. X plus 7 and x plus 7. 9 and 3 reduces to 3 over 1. And I think that's it. So everything that's left over is 2x times 3, so that's 6x. And down below we have x minus 7, x minus 5. Some of you might be thinking, well, why don't we distribute the bottom? Generally speaking, I would leave this in factored form. Okay? My math lab might tell you sometimes to distribute this out, but on exams, leaving it in factored form is perfectly okay. Now, multiplying and dividing are actually easier than adding and subtracting, because if you remember from fractions, adding and subtracting requires you to have common denominators. So just like with any fractions, common denominators can be tricky to find. In this case, these common denominators are already the same, so I don't have to do any work to get these guys to match. So I literally could go ahead and just add everything together, since they already have a common denominator. So I'm going to add together everything that's on this side plus everything that's on this side. So we have 2x squared plus 1 plus 3x squared. Of course, you're going to notice that I have common terms. I'm going to want to add those together. So that's actually 5x squared plus 1 over 2x plus 5. If at all possible, try to factor this and reduce further, but in this case there's nothing I can do to reduce or factor this numerator or this denominator, so this is fully simplified. Next page. Okay, on to the back side. Again, we've got a fraction. These fractions, you're going to need to find common denominators. So I've got 4 7s, and I'm adding 3 8s. Now I left myself a little bit of room so I can find a common denominator. Generally speaking, any common denominator will work. It doesn't have to be the smallest or the least. So if you would like to find any common denominator, an easy thing to do is just multiply these two things together. 7 times 8 is 56. So one of the common denominators will be 56. So how do I get to 56? Well, clearly I need to multiply this guy by 8. But whatever you do to the bottom, you're going to need to multiply also to the top. How do I get 8 and turn that into a common denominator of 56? We'll have to multiply by 7. But again, both top and bottom. So now what I'm going to do is I'm going to change 4 times 8 into 32 over 7 times 8, which is 56. Now we're going to add 3 times 7 is 21 over 8 times 7, which is 56. See, now they have common denominators. Now I can go ahead and add all of this together, because it's all over the same common denominator. 32 plus 21 is 53. Now, if there was anything I could do to reduce that fraction, I would do so at this point. So 53 over 56 is the final answer. You could also check this in your calculators, right? Because fractions without variables we can check. We have 4 sevenths, so 4 fraction 7 plus 3 fraction 8 brings us to 53 over 56, which is exactly what we have. Now, when we involve letters, it becomes a little more tricky. We can't use our calculator as a crutch, so we're going to need to find common denominators for this guy. Okay, so let's start just like I did the last problem by writing this out. I'm going to leave a space. The common denominator here, generally speaking, is multiplying these two guys together, or in this case, these two guys together. So my common denominator that I'm going to want to use is going to be x plus 4 times x minus 2. I'm going to multiply both together. So that means we're going to need to multiply this guy by x minus 2 and x minus 2, and then multiply this guy by x plus 4 and x plus 4. When you do that, you're going to have all of this plus all of this over this common denominator, which I now have. So let's go ahead and put all of this and all of this in the numerator. So I have x minus 3 times x minus 2 plus x plus 2 times x plus 4. Okay, at this point you do not want to cancel. We cannot cancel this family with this family because of the plus sign. Remember, anything that's being added to another term, you cannot cancel. So my only hopes of simplifying this further is to FOIL this out, combine like terms, and then see if something will cancel. And it turns out it might not, but I have to try. So when I FOIL this out, I'm going to get x squared minus 2x minus 3x, so that's minus 5x, plus 6. X squared plus 4x plus 2x is a positive 6x plus 8. Let's simplify. X squared plus x squared is 2x squared. Negative 5x and 6x is positive 1x. 6 plus 8 is 14. So the only thing left I could try to do is to factor this numerator. And it turns out I've tried and tried and tried, and nothing will factor this numerator into anything smaller. My hopes were to try to factor this into two binomials that multiply together, and then I was going to hope one of those binomials would cancel with one of these down here. But it turns out this is not factorable, so this is as far as I can go and is completely simplified. Alright, the last thing we're going to do is we're going to divide these complex rational expressions. And the reason they're complex is because you have a fraction with a mixed number, in this case it's a whole number, divided by a whole number and a fraction, all involved in a bigger fraction, so obviously it's very complex. So the first goal to do here is what you're going to want to do is you're going to want to set this equal to, you're going to want to find a single fraction. The goal is to get it to be a single fraction. So like one single fraction here divided by one single fraction here. In other words, I want to combine all of this together into one single fraction. So the way we're going to do that is we're going to need to find common denominators. Okay? So what I'm going to do is I'm going to start with 3 over 1 plus 1 over x. I want a common denominator, so I'm going to multiply this guy by x and by x, so that way we have a common denominator of x. Then I can add these together. They have that common denominator of x down here, and I can add everything that's up here, so 3x plus 1. 3x plus 1. Down here, I have 6 over 1 minus 1 over x. Well, again, I'm going to need a common denominator. So I'm going to multiply this guy by x and by x so that they have a common x in the denominator down here. And then I add everything in the numerator. So 6x minus 1. So now you'll see that I have a fraction divided by a fraction. And when we divide fractions, we simply just, oops, that's a 3, excuse me. When we have a fraction divided by a fraction, we flip the bottom fraction and we multiply. When we do that, you'll see that these x's will cancel because they're being multiplied, so we can cancel those. We're left with 3x plus 1 over 6x minus 1. That's our final answer. There's nothing I can do to reduce this further. This 3 and 6 cannot cancel because this term is being added to another term. Same goes for the x's, same goes for the 1's. Okay, last one. We're going to do the same thing that we did up here. Our goal is to get a single fraction divided by a single fraction. And you can see that we don't have these things added together. So we're going to try to add all of these items together. So we have 5 over 1 minus 1 over x squared. To find a common denominator, I'm going to have to multiply this guy by x squared so they have common denominators. When I do that, I'll have 5x squared minus 1 over x squared. See how those have common denominators? And all I did was subtract or add the two top numbers to create my numerator. In the bottom, I'll have 3 over 1 plus 1 over x squared. Common denominator is going to be x squared, so I'm going to multiply both top and bottom by x squared. So now that they have common denominators, I simply add the numerators together, so 3x squared plus 1. So what we're going to do is we're going to multiply the top times the reciprocal of the bottom. So 5x squared minus 1 over x squared times x squared over 3x squared plus 1. You'll see that both of these x's will cancel with both of those x's. So I'm left with 5x squared minus 1 over 3x squared plus 1. Final answer.